the daily view of our blue planet. This is a true privilege for the astronauts on the International Space Station, ISS. But can't we also take advantage of this unique view for science and research? The core of space-based Earth observation is sensors. These are highly precise optoelectronic masterpieces that have been observing our home planet for decades in various wavelengths and different spectral, spatial, and temporal resolutions. Satellites provide these sensors with a structure that keeps them in orbit in space, supplies them with energy, and sends their data back to Earth. All this and more is also made possible by the ISS, the largest human-made structure in the orbit of our home planet. And indeed, it has a unique potential for research in various scientific fields, including Earth observation. In doing so, the characteristics of the ISS differ in some aspects from those of typical remote sensing satellites. The ISS is manned and offers plenty of space for sensors. This allows for the installation of sensor systems and the use of new technologies without the need to build independent satellites. Additionally, astronauts can perform maintenance work and collect data flexibly. They can gather data, for instance, when spontaneous major events like volcanic eruptions occur. The relatively low altitude of the ISS is also advantageous, enabling high-resolution spatial imaging. Like most satellites, it is in low Earth orbit, but with its altitude of 400 kilometers, it is a full 300 kilometers closer to Earth. For example, the satellite Sentinel-2. Earth observation satellites usually orbit the Earth in a polar and sun-synchronous manner. They always fly over areas at the same time of day, typically recording only the daytime side. The ISS, on the other hand, orbits the globe on an inclined path that does not pass over the poles, and it switches from the day side to the night side every 90 minutes. This results in different perspectives and variable angles of capture under very different lighting conditions, because the Earth is a fascinating planet even at night. Let's now take a brief look at some important sensor systems located on the ISS, which, with their missions, advance the observation and exploration of our planet. The CEO stands firmly in the old space exploration tradition. For more than 50 years, astronauts have been giving us a new perspective on our planet through their photographs. As part of the CEO, the ISS crew uses commercial and professional digital handheld cameras with various lenses. Photos are taken from every available window on the space station, but especially from the cupola with its 7 windows, from the windows in the Russian Zvezda service module, and the nadir viewing window in the US Destiny laboratory module. The ISS also provides us with moving images. During the HDV experiment, from April 2014 to August 2019, 4 commercial HD video cameras were active on the external payload facility of the Columbus module, directed at Earth. Of course, the sensor systems on the ISS do not operate only in the RGB range. DESIS has been located on the MUSES platform since 2018 and is the second hyperspectral sensor system on the ISS, following HICO, which was operational until 2014. DESIS covers the visible and near-infrared range of the electromagnetic spectrum with high resolution. These characteristics qualify DESIS for applications in agriculture and forestry, land cover analysis, and multi-temporal environmental monitoring. JD is a very special sensor system. It does not work with the electromagnetic waves of the sun, but with its 3 system-owned lasers. As a result, precise measurement of forest and surface heights and the generation of a high-resolution 3D structure of the Earth is possible. Many other systems on board the ISS capture a wide range of phenomena and processes on Earth. From emitted thermal infrared radiation to ozone concentration to the movement of birds and mammals. In the 20 years that the ISS has been orbiting our Earth, it has become an indispensable platform for Earth observation. Numerous missions have been and are being conducted on it, which investigate and document the changes on our home planet, often triggered by our sensors. Space-based Earth observation plays a key role in understanding and preserving our planet. The ISS, a large, unique international project, also collects data. that is important for the present and our future on the blue planet.